graph of g of x is the image of the graph of f of x after a bunch of transformations. And so now we have to sort of work backwards. We've got both graphs, the original one and the new one. A bunch of things happened, and we have to write and verify the equation. So on my original graph, I have the points A and B. A is at 0, 8, and B is at 2, -8. Then if a bunch of things happen, it could be that we have two sets of arrows until we got to these blue points, A prime and B prime. A prime ends up at -2, 0, and B prime ends up at 0, -8. Now we did a similar question yesterday, but yesterday was easy because you could just, there was only one arrow, and you probably could guess and check and get it right away. With the two sets of arrows, sometimes you might guess and check for a while and nothing works. So I'm going to give you a systematic way to figure this out. And the systematic way means we have to find what the stretches and compressions were first. Because first the red graph is going to get stretched or compressed, and then it's going to get moved left, right, up, and down. Okay? So the way to figure that out, like some of you are going to be really good at this and just be able to look at the graph. Okay? Does it look like it's been squished vertically? Yeah, because this one seems dead. It seems like that's the case. Does it look any wider or narrower than it was originally? I'm not so sure. I think it might just be this, but we're going to check. So the mathematical way that you can check for stretches and compressions is by looking at horizontal and vertical distances between points. So if I look at horizontal distances first, and I look on my original one, when you go from A to B, can you see that going from A to B, no it's not, A to B this way, you go over 1, 2, 2 units. 2 units to the right, so I'll put +2. If it was to the left, I would put -2. And then if I look at the new graph, the horizontal distance from A to B prime, it's also a 2. There's been no change. So technically here, your x values got multiplied by 1. There's no horizontal stretch or compression. It's exactly the same width as before. Because from A to B was 2 units, and on the new graph it's still 2 units. But when I look at the vertical distances, again, first from A to B, now we're going down, because A started up above and we went down 16 units, so I'll write -16. And when I look from A prime to B prime, still going down, but only 8. Y would have to get multiplied by a half to change a -16 to a -8. So at this point, after you do that math, you can say, well, x doesn't change, but above here I can, above here I can write that I know that my only stretch, compression, or reflection, and you might get a reflection because if one went down and the other one went up, you'd have to multiply by a negative in there. But the only thing that's going to happen here is your y values are going to get cut by a half. And by doing that, I know that this point is 0, 4, and this point 2, -4. And once you find this middle point, the translations are easy. How do you get from 0 to -2? You would have to go 2 to the left. Does that work from 2 to 0? Yes. How would you go from 4 to 0? You would have to go 4 down. Does that work from -4 to -8? Yes. So we have to figure out the stretch compression first, what happened. And we can do that by analyzing vertical distances and horizontal distances. Some of you will be very good at it. You might not even write this down. You might just go and look at it and go, yep, y by half, and do that. And then go, oh, the x's look about the same distance apart. Write the middle points, and then the translations are easy to find afterwards. So now, can we write the equation, write and then verify an equation for the image graph in terms of, here's that language again, in terms of the function f. That means we need to have an equation, so it has an equal sign. We're going to need to have f on the right. If we look at everything that's happened, the y by half outside the function, here's f. Anything inside the function? Yes, 2 to the left. X's are liars. F of x plus 2. 4 down, outside the function. -4. And the nice thing about the method that we used is the method we used, actually this part here is your verification. You showed the points work. So we've actually verified it while we were doing the work. Because the question said to verify, verify usually means check your work, show that your work is right. And our process of finding the equation also showed that it was right. All right, question number 9.